What are those? Rewrite each as a decimal. So 1 divided by 2. 2 goes into 10 5 times, so 0.5. This one, 1 divided by 4. So goes in 0 times. 4 goes into 10 2 times. That will get me 8. 4 goes into 20 5 times evenly, so 0.25. 1 divided by 3 goes in, sorry about that. It goes in 3 times. That will get me 9. Oh, look, it's going to repeat. So 0.3 repeating. 1 divided by 9. It goes in 0 times. It goes in 1 time. Goes in 1 time. Look at that. It's going to be a repeating 1. How are the decimals in the first 2 fractions different from the decimals in the second 2? These are terminating, and these 2 are repeating. Okay. So, write an irrational number. So that means that irrational number can be pi, and then it can be the square root of something that is not a perfect square. And some of you may be asking yourselves, what's a perfect square? So perfect square, these are your perfect squares. 1 squared is 1. 2 squared is 4. 3 squared is 9, and so on and so forth. These are my perfect squares. So, something that is not a perfect square, 2. 11. Okay. Okay, then we're going to come here, understanding square roots. So, the first thing that we have to understand are, we're going to go back here to our perfect squares. Okay, so 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81. These are all ones that you should already know. These are ones that you should have memorized years and years ago. Okay? Those you should know off the top of your head without even thinking twice about them. Now, I personally think you should have memorized them all the way to 25, but that's just me. Recall that a square root is one of 2 equal factors. It means 2 times 2. These 2 are the same numbers. Okay, every positive number has 2 square roots, a positive square root and a negative square root. So, the square root of 4 is 2 and negative 2. Okay, we only most of the time use what's called the principal square root, and the principal square root is the positive square root. This symbol right here is called the radical. Okay, and it indicates a square root. The radicand is the part that is underneath the radical. It's read the square root of 25 or as radical 25. Remember that a perfect square is a number that is equal to the product. It's equal to a number that you can rewrite as a number multiplied by itself. So, The square root of 1. Well, that's the same thing as 1 times 1. So 1. This is the same thing as 2 times 2. It's 2. This is the same thing as 3 times 3. 3. This is the same thing as 4 times 4. 4. Same thing as 5 times 5. That's 5. 6 times 6. 7 times 7. 8 times 8. Are you getting the hang of this? Okay. 13 times 13. 14 times 14. And 15 times 15. Okay. Those are ones that you definitely should know off the top of your head. Okay. So what is the value of the square root of 0? Well, what times itself gets 0? What times itself gets 0? 0. Because it has to be two numbers that are exactly the same. Do you think the square root of every number will be the result in a rational number? Well, as I said, in order for it to be a rational number, underneath the radical sign, the radicand, actually I want to write the radicand has to be a perfect square. For the number to be rational. Now, notice how I didn't say it has to be a whole number under there. Okay? So what times itself gets 25? Well, 5 times 5 is 25. So now look at this. This one, oh, I'm sorry. Use a calculator to evaluate the square root. Okay, so if I looked at this, 25 is 5 times 5. Well, in order to get 0.25, it would be 0.5 times 0.5. So 0.5 is my answer. Now, if you look at this, this is the same thing as saying 25 times 10. So this would be 5 times 5, but then we have this 10 over here. So yeah, we have a perfect square with the 25 part, but we do not have a perfect square for 250. So if I was to plug it into the calculator and I wanted to take the square root of 250, I would get approximately, it wants to the 100,000ths. So this is the tens, hundreds, thousands. Okay? Over here, 5. There's nothing times itself that's going to get 5. So this is going to be approximately 2.236679. This one, nothing times itself is going to get a negative number. This is not possible. Because both underneath it would both have to be negative numbers. Negative times a negative. Well, negative times a negative is positive. It doesn't work. So 2.5 and taking the square root of, 2.5 and taking the square root. That would get me approximately 1.581138. Oh, look at that. Aren't these basically the same numbers? Notice how we just moved the decimal over 2 times? Okay, this one. Now this one, this is the same thing as saying 25 times 100. This is the same thing as saying 5 times 5 and 10 times 10. I'm guessing that when I plug it in, I'm going to get 50. Oh, look at that. I got 50. This one, I don't know that off the top of my head. Actually, I do, but this is the same thing as saying 26 times 26. So that would get 26. Okay, so over here, this would be 676 times 10. So this is 26 times 26 times 10. So this part's perfect square, but this part is not. That makes it an irrational number. And so we're going to take the square root of that, and we get approximately 82.219219. Okay, and then basically the same number. I'm going to take a wild guess. It's going to be 2.6. It is. How did I know that? Because 676 without the decimal we just found a minute ago was 26, and there are 2 decimal spots. This, on the other hand, is not going to be like that. 7.6, take the square root of that. It's going to get approximately 8.2219219. I think that's the same as this one over here, just moved. And again, you can't have a negative underneath this, so this is not possible. You will get an error on your calculator. Okay. Okay, what do you notice about the square roots of rational numbers? They have a terminating number. Is the square root of a whole number always a rational number? Well, 250, wasn't that a whole number? And its answer was 15.811388. That's approximate. Okay, so no. Is the square root of a decimal always irrational? Well, a minute ago, didn't we do this one? And this came out to 0.5 times, I should put 0.5, times 0.5, which the answer to that is 0.5. So, no. Okay, we're going to look at Penelope and Martin's statements and reasoning. I know that 144 is a perfect square. Therefore, the square root of 144 is a rational number. I can move the decimal point to the left, and 14.4 and 1.44 will also be rational numbers. Likewise, I can move the decimal point to the right so that 1,440 and 14,400 will also be rational numbers. Well, guys, look up here above. When I had 25, square root of 25, I did get a rational number. Okay, when I moved it 2 decimal spots, I still had a rational number. But guys, when I moved it 1 to the right, didn't I get an irrational number? And when I moved it 1 to the left, I got an irrational number also. So that is not going to be true. She is not going to be correct. I know that 144 is a perfect square. Therefore, the square root of 144 is a rational number. I can move the decimal spot 2 places to the right or left and get a perfect square. That is correct, boys and girls. In other words, 1.44 and 14,400 will also be rational numbers. That is absolutely correct. Okay. We're going to estimate our square roots. The square root of the square root of most numbers is not an integer. You can estimate square roots of numbers that are not a perfect square. Begin by determining the two perfect squares closest to the radicand, so that one perfect square is less than the radicand and one perfect square is to the greater than the radicand. This part is actually easier than what you think. Then consider the location of the expression. Okay, so I do it a little bit differently than they do. Okay, but no, it's not. Okay, so we're starting off with the square root of 10. So the perfect squares that are closest to the radicand of 10 are 9 and 16. So if I took the square root of 9, I get 3. If I take the square root of 16, I get 4. So that means that this has to be between 3 and 4 somewhere. Has to be between 3 and 4. Now, let's look at it. 9 to 10, that's one number away, and 10 to 16 is 6. So this means it's going to be closer to the square root of 9. Okay? So, think about the location of the square root of 10. So, do you see how much closer 9 is to 10 than 10 is to 16? Now, they already tell you it's 3.2. Now, what I'm going to say is let's figure it out. Well, if I had 3.1, that's going to give me 1, 3, 3, 9, 1, that's going to be 6, 9, 2 decimal spots. Or if I have 3.2, that's going to be 4, 6, sorry guys, 6, 9, this is going to be 12, 10.24. Which of these two numbers? Sorry. So this is actually closer. Okay. So we're going to look at each one of these expressions and we're going to put the expressions from least to greatest. Well, what's the smallest number? 8's the smallest number. So the square root of 8, the square root of 45, the square root of 70, and the square root of 91. Guys, you just look at the radicands. What's the smallest? What's the greatest? Now we're going to locate the approximation of each. I am so sorry. Luna. Okay. Shh. This is between 4 and 9. It's closer to 9. The square root of 9 is 3. So the square root of 8 is going to be somewhere here. Then we have the square root of 90. Okay? So what perfect square? Well, 81 and 100. From here to here is 10 away. From here to here is 9 away. So it's going to be almost in the middle, but closer to 10. So here we go. Sorry about that, everyone. Then the next one is the square root of 70. So we have the square root of 81 and the square root, that's 9 squared, so 8 squared, 64. So from here to here is 6 away. From here to here is 11 away. So it's closer to the square root of 64, which is 8. I forgot what the number was, 70. Holy moly, you guys. The square root of 36 and the square root of 49. This is 4 away. This is 9 away. So it's closer to the square root of 49, which is 7. So approximately right here. Okay. Now, we're supposed to do to the nearest tenth. So if I have the square root of 8, let's see. The square root of 8, we just said, is between the square root of 4 and the square root of 9. So that means it's between 2 and 3. It's much closer to this. So I'm going to go with, I don't know, 2.9. So I'm going to multiply 2.9 by 2.9. And that's going to get me 81. That's 18 plus 8, 26. That's 18. Carry the 1. That'll get me 5. So that's going to get me 1. That's going to get me 4. 8.41. If I took 2.8 times 2.8, that's going to get me that's not that number. 64. I carried it to the wrong part. That's going to be 16 plus 6 is 22. That's 16. That's a 5. 4. That's an 8. That's a 7. So 8 is in between these two numbers. Which one is it closer to? It's 0.41 away over here. It's 0.16 away here. So it's closer to this one. So the square root of 8 is approximately 2.8. See how the 8 is in between these two numbers? Okay, so we're going to do our next one. What is our next one? 45. Change my color. So the square root of 45. It's between the square root of 36 and the square root of 49. So it's between 6 and 7. It looks like it's closer to 7. It's only 4 away. So I'm going to pick, I just randomly going to pick, it's higher than halfway, so we're going to pick 6.7. That's 49, 42, 46. 36 plus 4 is 40. That's 9. That'll get me 8, 4, 4, 2 decimals. 44.89. Look at that. It's pretty close to 45. So let's go up 1 and see how close it is. That's 64. That's 48. So 54. That's 48. 36 plus 4 is 40. So 4, 2, 6, 4. 46. Which one is it closer to? It's 0.11 away here. It's 0.24 away here. So it's closer to this one right here. So square root of 45 is approximately 6.7. Okay, so let's look at the next one. I don't know. And that's going to be 70. So that's between 64 and 81. That's 8. This is 9. This right here is, what did we say, 6 away. This right here is 11 away. So it's a little less than halfway. So 8.4 and 8.4. That's 16. That's 32, 33. That's 32. That's 64 plus 3, 67. 6, 5, 70.56. Okay, so that's a little above. So we actually need to go below and go to 8.3. When I multiply these together, I get 9, I get 24, I get 24, I get 64, 66, that's 9, that's 8, that's 8, that's 6. Okay, it's definitely closer to this, so the square root of 70 is approximately 8.4. Okay, and last but certainly not least, the square root of 91, that's between 81 and 100. That's 9, that's 10. From here to here is 10 away, from here to here is 9 away. So I'm going to say halfway between is pretty good guess. So 9.5, multiply those and get, 25, that's 45, so 47. That's 45. 81 plus 4 is 85. So that's a 5, that's a 2, that's a 0. That's a 90.25. Oh, so let's try one more up. So that'll get me 36. 54 plus 3 is 57. 54. 81 plus 5 is 86. So that's a 6, that's a 1, 2, 92.1. It's closer to this, so the square root of 91 is approximately 9.5. Okay. So when you're solving an equation like this, remember, it's what can I plug in for this right here that I'm going to get this number here. So if I was to take the square root of both sides, I would get x. And then what times itself gets 25? It's actually 5 and negative 5. Because, check your answer. If I did 5 squared, I would get 25. If I did negative 5 squared, I would also get 25. That's why we get two answers. Sometimes you'll see this written as this, the positive and negative of 5. So the same thing happens here. I take the square root of both sides. This is going to get me a, it's going to get me the positive and the negative, but 13 is not a perfect square. So I need to figure this out. So 13, that's going to be between 9 and 16. This is 4 away. This is 3 away. So this, oops. Okay. That's weird. Okay. For some reason it wasn't writing for a second there. Got 3 here, got 4 here. So it's almost in the middle, a little bit closer over there, but I'm going to try 3.5 and see what I get. That's going to get me 25, 17, that's going to get me a 15, 9, 10, 5, 2, 2, 1. So 12.25, so I need to go up 1. Ouch. So that's going to get me 36. That'll give me 18, 19, 21. That'll give me 18. That'll get me 9, 10. So 6, 9, 2, 1. Oh, look at how close this is. There's nowhere we're going to get any closer to 13 than that. So this is approximately 12.96. So over here, we're going to get approximately 12.96. This should say approximately, not equal to, because it's not a perfect square. Over here, again, take the square root of both sides. This is going to be approximately, because 80 is not a perfect square. So 80 is between 64, is that right? Yeah, and 81. Look at how close that is. That was a horrible 8. That's going to be super duper close to 9. So I'm going to pick 8.9 and 8.9. It's 8. 72 plus 8 is 80. That's going to get me 72. 64 plus 7, 71. 1, 2, 9. 79.21. Okay, I can't go up any further, else I'd be at 9. So this is going to be approximately 8.9. Okay, this one, I take the square root of both sides. G is going to be approximately positive and negative. So let's look at 53. So that's between 49 and 64. So between 7 and 8. This is only 4 away. This is 11 away. So it's going to be much closer to that. It's not even halfway. So I'm going to pick 7.3. And I just picked these numbers randomly. I don't actually know what the answer is. 9, that's going to be 21. That's 21. That's 49, so 51. This is 9. This is 1. That's 3. That's 53.19. Oh, that is super, ooper, duper close. So we're going to go with it's approximately 7.3. Okay, next we have the cubed roots. So I'm going to change colors. So cubed roots. So if I have 1 to the third power, it's 1. 2 to the third power is 8. 3 to the third power is 27. 4 to the third power is 64. 5 to the third power is 125. 6 to the third power is 216. Now we're starting to get to the numbers I don't know. Let's see, 49 times 7. It's going to be 343. Oh, now we're definitely to the ones I don't know off the top of my head. Okay, so 64 times 8, 512. 9 to the third power. Actually, no, this one, I think 729, I think is what it is. Yep, 729. And 10 to the third power is 1,000. 11 to the third power is 1331. And 12 to the third power, I definitely don't know. 1728. Okay? Now you should have a little sheet that gives you all of those. Okay? So use unit cubes to build 3 different cubes in the given sides. Okay? So build unit cubes. So if I had 1 times 1 times 1 times 1, I would have 1. If I had 2 times 2 times 2 times 2, I would have 8. If I had 3 times 3 times 3 times 3, I would have 27. And then I would have 64. Okay? You just calculated the volume of 3 cubes, where the first 3 counting numbers. Okay? We've already done that. Awesome. Oh, I just did that with you. If you know the volume of the cube, you can work backwards to calculate the sides length of the cube. For example, to determine the side lengths of a cube, the volume is 125. What times itself 3 times is going to get 125. 5. 5 times 5 times 5. Okay? This is called the cubed root. We're going backwards. Okay? This right here is telling you 3 times cubed. What times itself? That, by the way, is called the index number right here. What times itself 3 times is going to get that number. Okay? So now we're going backwards. What times itself 3 times will get 1? 1. What times itself 3 times will get 27? 3. What times itself 3 times will get 125? 5. What times itself 3 times will get 343? 7. What times itself 3 times will get 729? 9. We're just going backwards. What times itself 3 times will get 8? 2. What times itself 3 times will get 64? 4. What times itself 3 times will get 216? 6. 8. 10. Okay? What is the side length of the largest cube that you can create with 729 cubes? Well, that's it right there, 9. Will it always be a whole number? No. Cubed root of 2. Not going to happen. Okay? So, we're going to do the same thing we did a minute ago. Except for instead of doing square roots, we're going to do cubed roots. So yes, it's going to take a little bit more time to do. It's okay. So here we go. Okay, perfect cubes. So 100. I know we have to go back all the way to here. 100 is between these two. So 4 to the third and 5 to the third. So this is between 64 and 125. Okay, this is 36 away, this is 25 away, so it's probably going to be a little bit closer to the 5. Not a ton closer, but a little bit closer. So, I don't know, 4.6? I'm going to say 4.6. So that 36 is going to get 24, 27, 24, 16, 18, 1, 1. Now some of you are going to stop right there, but it's to the third power, so I still have to multiply it one more time. That's 6, 9, that's 6, that's 12. Then I do the 4, that's 24. That's 4, 5, 6. That's 4, and that's 8. 6, that's a 3. That's going to be 8, 9, and 9. 99.336. So I'm going to guess that it's probably not going to get any closer than that. So that's approximately 4.6. Okay, 175. Okay, that's going to be between the cubed root of 125 and the cubed root of 216. Okay, it's 50 away here. From here to here, 25, 41 away. So again, this is 5, this is 6. It's going to be closer to the 6, but not by a whole lot. Do 5.6. 36, 33, 30, 25, 28. Two decimal spots. 5.6, 36, 18, 21, 6, 7, 8, 18. That's going to get me 30. That's 15 plus 3 is 18. That's 5 plus 1 and 15. The 3 decimal spots. Oh, look at that. Look how close that is to that. So this is going to be approximately 175.616. Oh, what am I doing? No, it's not. 5.6. There we go. And last but not least on this part, this is going to be between the cubed root of 216 and the cubed root of 343. And from here to here, it's 40 away. From here to here, it's... Actually, I don't know. 7. I can't even do this in my head tonight. 343 minus 256. 87. Oh, it's going to be much closer. Not even halfway. So much closer to the 6. So I want to say 6.3. That's 9. That's 18. That's 18. That's 37. That's a 9. That's a 16. That's a 9. That's a 3. There's not a lot of space, but I'll try and fit it in. 27. 18. 20. 27. 29. 9. 11. 6 times 9 is 54. 36 plus 5 is 41. 54, that's 58. That's 18 plus 5, so that's 23. 7, 4, 0, 0, 5, 2. Ooh, it's 250. I better try 6.4. And we 16, that's 25. That's 24. 36, 38. 6, 9. 40.96 times 6.4. That'll get 24. That's 36, so 38. That's 16. Multiply by 6, that gets me 36. That's 54 plus 3, 57. And that's 24. So this is 4, this is 4, it's 11, this is 12, that's 6, that's 2. Let's see. This is 250, this is 262. This is almost 6 away. This one, ooh, these are really close. So 256 minus 250.042 gets 5.9. 5.8 away, and 262.14 minus 256 gets 6.1. 6.1. So that means this is approximately 6.3. Okay. Awesome. So this next part, we're doing the same thing we did on the last part, except for we're taking the cubed root. Now on this one, it's not going to be plus or minus, because you can't do negative times a negative times a negative and still come out with a positive number. So this is just going to be 3. Now on this one, I have to find what it is approximately. So 31, oopsie daisy, is between 8, cubed root, 27, and that's 3, then 4 is 64. Oh, that's definitely going to be closer to 3. So 3.2. 4, 6, that's 6, 9, 4, 12, 10, and then multiply by 3.2 again. That's 8, 4, 0, 2, and 12, 7, 0, 3. That's 8, 6, 7, 2, 3 with 3 decimals. This is 32 point. Oh, so I have to try it down to 3.1. So 1, 3, that's a 3, 9, 1, 6, 9, and 3.1. So that's 1, 6, 9. That's 3, 18, 28. So 1, 9, 7, 9, 2. Which one is closer? Good question. Let's see. 32.768 minus 31 get me 1.768, and 31 minus 29.791 will get me 1.2. So this is approximately 3.1. Okay, and the cubed root of 512. Well, let's look back up here. 512. Oh, look at that. Isn't that just 8? Isn't that nice? So this